So many people got good grade, and I'm glad to see that. And so let me start the section 2.7. And for the two people just come, what are your names? You're Vikram, right? And again, please. Carrington, right? Yes. Okay, today we're studying section 2.7 about the derivatives and rates of change. So we have reviewed into 2.1 the tangents and velocity, which are the ingredients for defining derivative. And the rates of change for today. So let me quickly review what the tangents is. So suppose this is a Cartesian coordinate. And the graph of a function is like this. This point, we call it the point P at x is equal to a. This is the function f of x. So it means that this point should has a value of f of a. So any line that goes through P and cut the graph at 2 points, we call it a secant lines, right? And this line, the red line here, is a tangent line. Suppose the position of Q is at x and f of x. We see that as x come close to a, Q will come close to P, right? In this way. We'll go this way. And if it come closer, and the line PQ will approach the red line here. And this is called the tangent line. And this, the change, okay? The slope of this line, we call it M. PQ is the limit. Okay, let me just write it in forms, in details. Okay. Definition. The tangent line to the curve y equal to f of x at the point P at x is equal to a, and value of that is f of a, is the line through P with the slope m in this case, right? And m is defined as the limit when x approaches a, f of x minus f at a divided by x minus a. And provided that the limit exists. Okay? This is just a definition. Let us go to an example and see how it looks like. So, find an equation of the tangent line to the parabola y equal to x squared at the point P 1, 1. Okay? Now, let me just remind you the slope, the graph of this function. Is like this, right? And they ask us to find a slope at this point, which is this line, okay? We see that here, in this case, a is equal to 1, right, in this specific case. And f of a is f of 1, which is 1 square. This is 1, right? So it means our p is right here. Okay? And the function f of x is given in this form. So the slope of this is m is equal to limit when x approaches 1, f of x minus f of 1 divided by x minus 1. Okay, from definition. So put everything into the formula. We know that limit when x approaches 1 of f of x in this case is x squared minus 1 divided by x minus 1. Okay? Look at this. This is a root function. And it is undefined at 1, right? It has a removable discontinuity. Okay? If we put 1 here, it will be 0 over 0, which is not defined. It means we cannot evaluate the value of this to get the limit. Therefore, we need to simplify it, right? We see that x squared minus 1 is x minus 1 times x plus 1. And the denominator will be just rewritten. Then here, in the numerator, there's x minus 1. And there's x minus 1 in the denominator. So it cancels each other, right? So the limit becomes limit when x approaches 1 of x plus 1. we see that x plus 1 is a linear function, or it is a polynomial. Therefore, it is continuous on its domain. And the domain of this is R, right? Or from negative infinity to infinity. Therefore, it is continuous at x approach is equal to 1. It means the value of this limit is the evaluation of this, which is 2, right? So we have the slope of this line. Therefore, the equation of the tangent line at this point is y minus y1 is equal to m times x minus x1. In this case, y1 is 1, and m, we just found it here, is 2, and x1 is 1. So this is the equation of this. Or we can write it as y is equal to 2x minus 2 plus 1, which is 2x minus 1. We've done that before in section 2.1, right? Okay, let us continue. In general, we see that this is the graph of a line, of a curve. Let us say this, okay? And at this point, we call it P. They're similar to the previous one graph. This is f of A. So we see that this is a secant line. We use a different notation, right? Suppose we consider this point here is the point A plus H, right? C. So this distance is H, right? And this, the change in Y is f of x plus H minus f, that is f of A. Yeah. Just okay, different way to say it. So it means that m, the slope of PQ is f of A plus H minus f of A divided by H when, okay? Then the definition of tangent lines becomes the limit when H approaches 0 of f of A plus H minus f of A divided by H, okay? Just a different way to find the slope of a tangent. Different way to write it. Either way is fine. So now, let me remind you a second concept, the velocity. Okay. Now, suppose that this is the distance we are going from the time t is equal to 0, and at the time t is equal to a, we are at this position right here. And at the time t is a plus h, we are at this position. So the change here, so this distance is f of a, right? And in this case, fx is a position function. And here, at the time t is equal to a plus h, this is f of a plus h. So we define that the average velocity will be the displacement or the change in position divided by the change in time, which is in this case f of a plus h minus f of a divided by h, or from the previous definition, this is also the slope, right? The slope m of the function f of x. So when the velocity, or it is the instantaneous velocity v at a at the time t equal to a is defined as v of a is equal to the limit of the change in position and h approach 0. Okay? Now let us consider a problems that we did already in the section 2.1. Now a ball is dropped from 190 meters above the ground. First, find the velocity of the ball after 5 seconds. The second question is, how fast is the ball? Traveling when it hits the ground. Okay? The first question from definition. So the equation of motion, let me read, is given by S of t, which is the function 4.9 t squared, okay? Where t is in seconds. Okay, from definition, we see that the velocity at any time t is given by a limit when h approaches 0 of the function f of t plus h, subtract f at that time t, divided by h. Okay, then f of t plus h is, what is it? 4.9 plus h squared, right? We put that into the position equation. And the second is f of t is 4.9 t squared. The denominator is simply the constant h here, h. So now we see that in the numerator, 4.9 is a common factor, right? So we can factor it out, make it simpler. What is left inside the parentheses here? Let us use a bracket here. What is it? Louder? This guy, right? T plus h squared and t squared. Okay? Then here it is. We just write it here. Minus t squared. Okay? So we can eliminate the parentheses inside, extract it. It is t squared plus 2t h plus h squared minus t squared, right? Divided by h. We see that here, there's t squared here and negative t squared. They cancel each other, right? So other terms, the other two terms, what is the common things about these two guys? Very good. H here, it means that, again, we can factor it out, right? The number, we just rewrite it. When we factor h out, the parentheses here will be two t plus h, right? Again, look at this. This fraction, they have h in the denominator and h in the numerator. So they cancel each other, right? They cancel each other, then it becomes, what is it here? 2t plus h, right? Now, this function is a polynomial in terms of h, right, with a degree 1. So it is continuous in R, therefore it is continuous at 0. So it means that we can substitute the value of h is to be 0 right here. Therefore, the limit will be 4.9, and we substitute h is equal to 0, then it disappears here. It will be 4.9 times 2t, right? Which is 9.8 t with any t. Is it clear? So we have the velocity at any time. So we are asked to find the velocity at t is equal to 5. So we can simply substitute this into the previous result, which is 9.8 times 5, right? So it is 49 meters per second. Remember, the unit here is meter per second because the velocity is the fraction of the change in distance over the change in time, right? The distance we use in meters and times is second. That is why we have the velocity is the unit of meter over second. Okay? Is it clear? Very good. Now, look at this. In the second question, we see that, okay, suppose we don't know at the time t is equal to 0, the ball is here. After some times t is equal to t0, let us say t0, or let us call it t star. It hit the ground here, right? Therefore, the distance here, we know that the distance here is given as 490 meters, right? And at here, at the time t, let us call arbitrary t right here. Let us just call it t to make it simpler. Okay, at the time t. So we know that s at the time t is 490, right? That is what we're given. So from the equation, we know that s of t is 4.9 t squared, right? Put it in here, and the right-hand side is 490. Therefore, we divide both sides by 4.9. We have that t squared will be 490 divided by 4.9, okay? Which gives us 100. Okay, t squared is 100. Therefore, t should be square root of 100, right? And t, we just is time, so we take the positive value, so we don't care about the negative value of this. So it means t is equal to 10 seconds, right? It means that after 10 seconds, the ball will hit the round. And the velocity of that point will be the velocity when it hits the ground will be the velocity at t is equal to 10. And from the previous result, it is 9.8 times t, which is 9.8 times 10, and it is 98 meters per second, right? Is it clear? Very good. So now let us take a look at the new concept, derivative. So in general, for any function f of x, the derivative of this function at a number a is given by this. We denote it as f prime at a here, is the limit when h approaches 0 of f of a plus h minus f at a when h divided by h. So And definitely the limit should exist, right? If it is exist, then we have the derivative. So, or we can write it as f prime, the derivative of f at a, is the limit when x approaches a, f of x minus f of a divided by x minus a. They're the same thing, okay? Now, from this definition, let us find the derivative of the function here. F of x is x squared minus 2x plus 3 at the number a. Okay, so we have the definition of this. Then what we need to do is to compute it. F prime at a will be the limit when h approaches 0 of f of a plus h minus f of a divided by h, right? So now this function, the input is a plus h. We'll substitute that into the value of x here, right? It means it is the limit when h approaches 0 of a plus h squared minus 2 times the input a plus h plus a constant 3, right? That is the first guy. Subtract the second guy, which is x squared minus 2x plus 3. So let us put it in the bracket here. Okay? Be careful. And the denominator. Here, we should be very careful because here this is a negative sign. So when we remove the parentheses here, the constant 3 will cancel with this number 3 right here, right? Therefore, this limit when h approaches 0 will be, so let us expand this one. It is a squared minus 2ah plus h squared minus 2 times a minus 2h minus x squared. When we remove the parentheses here, remember to change the sign. Okay? And this is the denominator. Remember here, this is negative sign. Therefore, we have this is positive, and this guy is positive, then we change the sign to be negative. So just be careful. Now, we see that, actually, at the point A, then this guy should be A, right? Sorry. This should be A. This should be A as well. Sorry about this. It is a specific number. So this guy here is A. Okay. Now, again, we see that this is a squared. We'll cancel with a squared here, right? And this negative 2a will cancel with positive 2a. Okay, so let us rewrite it. It becomes limit when h approaches 0 of 2ah plus h squared minus 2h, and the denominator is simply h here. Now, again, in the numerator, there is h here, h here, h here. So the common factor of this would be h, right? So let us factor it out, right? When we factor h out, the first terms will be 2a plus h minus 2, okay? Then we see that the numerator, there's the terms of h, and the denominator also have this term. Therefore, they cancel each other, okay? Then when h approaches 0, this function is continuous at 0. It is continuous at 0. Therefore, we can substitute the value of h is equal to 0 to this one to find this limit, which is 2a minus 2, right? Well, let me write it clearly. It is limit when h approaches 0 of 2a plus h minus 2, and it becomes 2a minus 2. So we have that the derivative of the function f at a is this guy. Okay? Is it clear? Very good. Now, therefore, we can also find the tangent line of this guy, right? Let me see. Therefore, the tangent line of the curve y equal to fx at the point P A f of a is given by y minus f of a is equal to f prime at a times x minus a. Okay? It's similar to the tangent. Yeah. The slope. Yeah. Previously it was the slope m at this point, right? Nothing's new. So we have a new concept, rate exchange. Okay? Rates of change. Okay, now for any function f of x, x is here, the y coordinate is like this, and suppose it is like this. Okay. Now, suppose we consider at this point, so therefore the slope, the tangent line at this point will be the red line right here, right? And the slope of that will be m is right here. Another point here, the slope of this guy will be this blue line here. We call it M2, and this guy we call it M1. We see that M2 is smaller than M1, right? And it means that the rate, the y coordinate, the y value change slowly compared to the y at this point, at the first point. Suppose this is the point 2, this is point x1, right? Or a function at this point, if it has the first derivative bigger than another point, then it means that it changes in value y faster, more stiff, right? Very good. So, the average rate of change of y with respect to x over the interval x1, x2, and we see that this is f of x1 is right here, right? This guy is f of x2. So we see that dy over dx is f of x2 minus f of x1 divided by x2 minus x1. So we call the instantaneous rate of change of y with respect to x at x is equal to x1 is the limit of delta x approaches 0 of the ratio dy over dx, which is also the limit when x2 approaches x1 of f x2 minus f x1 divided by x2 minus x1. Or in this case, it is also f prime at x1, right? So we see that if f prime at a is large, this implied y value change fast, right? Or if f prime at A is small, then the y value changes slowly. So if we're talking about the particle moving in the space, then the speed of that particle is the absolute value of f prime at that point. So there are some more minutes left. Do you have any questions for me so that we can discuss here? Or is the homework 2.5?
How does the quiz work Friday?
It's a good question. I'm going to give a quiz online. I'll send it via email. And your job now is to find a team so that you can work together. So a team would have at least 3 to 6 people. Okay? So each of you, is up to you. Just the whole team will give one answer to the whole quiz and submit it to me. Then I will grade it, and the whole team will have the same result. That is for extra credit. So that if you got minor mistake in the exams, I will just ignore some of these. But make sure that every one of the people in the group, every person has to understand the whole quiz, okay? I may ask you to explain what is written in that. If you cannot answer that, you will not get a point, okay? So I am going to give a paper pencil test, and I'm going to send you the test before the test day. And you cannot access to that file because it will has a password. On the exams day, I will let you know what the password is, and you can open it on your computer if you are doing at home. You cannot come here. If you're here, you could. I'll send it a paper's test. Okay? So that, and one more thing. I am also sending you an email asking you about the times possibilities. I mean, the time after class and before class, if you are free, and I will kind of estimate the time of the test. Make sure that it will not have any conflict with your other courses. And if you may somehow miss a test, we'll find a way later. Okay, thank you so much and have a good one. Remember that we check your homework due.
I have a question.
Sure.
Will the quiz going to be on derivatives?
I'm not sure yet. Don't worry.
If it is,
I'll send it on Thursday.
Email?
Yes, email. I'll notify you when I send it. You're welcome. Sorry.
it's fine. If there is the question is about derivatives, will we get points off for using the power rule? Or do we have to use f of a plus h?
Just follow the definition.
Okay.
Yeah.
So the test is online?
The test is paper and pencil. If people cannot come here, they can do it and proctors via Zoom.
Okay.
Yeah.
So we'll do it in here on.
If you're here, yes.
Okay.
If you're here, It's not on Friday, but the week after that.
Okay,
This Friday is just the time for the quiz, so that you have an idea how we are going to do with the test.
so the quiz will be online and the test is next week.
Yes,
Okay, got
you have a
Thank
good
you.
one. You're welcome. See you.
Oh, I was just gonna say I'm here. I don't know if you got me for attendance.
Jackson, right? Yes, if you're here, don't worry. I can find the report of your attendance. Don't worry.
Oh, okay. All right. Thank you.
You're welcome. Have a good one.
You too.
Bye-bye.